Section 6.5 is equations containing radicals. And the objective here is going to be to solve and check equations that have radical expressions in them. A bit of a word of advice is to solve radical equations simply by isolating the radical expression. Then square, or in general, raise both sides to the power equal to the index of the radical expression. Now, a small little hint would be that when there is an equation that's a bit complicated, that you let the radical equal some dummy variable u, and then just solve for u, and then go ahead and set that answer for u equal to the radical expression to figure out what, say, x was or y was or whatever the variable is you're looking for. So let's take a look at some examples to see what that means. So in example A here, we're going to take a look and see that the radical is already isolated. This radical 3x minus 1 already is alone by itself, so there's no need to isolate it. So step 1 we don't have to do. Step 2 says to raise it to the power of that of the index, which just means because it's a square root, we need to square both sides. So for part A, we start by squaring both sides. So that was the original. Square, square, a square and a square root cancel, leaving behind just 3x minus 1 on this side, and on this side is 16. If I add 1 and divide by 3, I get x equals 17/3. Now, for all of these possibilities, we need to make sure that we check our solution, because we're going to see that some of our answers, when we have radical equations, are not actually true. They're extraneous solutions, and we have to reject them. So what we're going to do is we're going to check all of these possibilities for any type of equation that has a radical involved in it. So we go ahead and we check, and we say, well, let's check that x equals 17/3. And we remember that a check is always valid if you check it in the original equation. So we have square root, and this is 3 times whatever x was, which is 17/3, minus 1, and that equals 4. So again, we're just checking that 17/3 is our solution. The 3 here and the 3 here cancel, leaving behind 17. That's 17 minus 1. 17 minus 1 is 16. Well, the square root of 16 is indeed 4. Part B. Now, part B is one of those examples where it might be useful to let the radical component of the equation equal some dummy variable. So let's do that for this part. So for part B, I'm going to start by saying, all right, well, here's my equation. 2 times the cube root of 2y plus 2, that whole thing, plus 3, equals 7. Now, for this problem, let's start by saying, well, we'll let u equal whatever the radical expression is, which is the cube root of 2y plus 2. Okay, we'll start with that definition right there. Let u equal that. Well, if u is equal to that quantity or that expression, then we can replace this entire thing right here with u. So this, in a sense, is like substitution method. Replace this with a u. So this becomes 2, and instead of that whole thing, u now, plus 3 equals 7. And if we go ahead and solve this for u, we're going to subtract the 3 and divide by 2. We'll end up getting u is equal to 2. Now, if u is equal to 2, we have to remember to ourselves that we're not looking for u. We're looking for y. But isn't u equal to this expression? And u is also equal to 2. So, right, by the transitive property, we know that if u equals this and u equals this, then these things must be equal to each other. Like our chain rule in a sense, okay? So set these two equal to each other. So again, we solve for u, but that's not our intention. Our intention is to find y. So we go ahead and we replace this u with the definition of u, which we came up with earlier. So the cube root of 2y plus 2 is what equals 2. And now what this has done is this allows us to isolate our radical without having to worry and remember some of our rules along the way. Now, again, it's completely fine if you go ahead and just start this problem by adding this 3, dividing by 2, and get that by itself. That's totally fine. You don't need to use u substitution here. But it's just a technique that you're going to learn. You're going to use it later on to help you with equations that involve rational expressions, so fractions. Or in calculus, you'll learn about something called u substitution, which is a useful technique, and this is a bit of a preview of what it looks like. So anyhow, with that said, let's take a look here. We have a cube root equals 2. So how do you get rid of a cube root? You have to cube both sides. Or as we said earlier, raise it to the power that's equal to the index. Well, the index was a 3, so we raise it to the third power right here. So raise both sides to the third power. Well, the cube root of a cube just becomes itself, so this is just 2y plus 2. And that equals 2 cubed, which is 8. Subtract 2, divide by 2. We're going to get 6 over 2, so y is equal to 3. Now we have to check this, right? So let's check that y equals 3. To see if y equals 3, we plug it back into our original equation. So in our original equation, if you remember, we had 2 times the cube root of, and it was 2y plus 2, so it's going to be 2. Now y, again, is 3, right? 2 times y plus 2. That whole thing plus 3 equals 7. So we go ahead through the process. We get 2 times the cube root of, well, this is going to be me 6 plus 2 is 8. So I can close my radical right there to make it easier. And I know that this is going to be plus 3 equals 7. I continue to only simplify the left-hand side. I don't touch the right-hand side. I don't move anything from side to side because it's a check. This becomes 2 times 2 plus 3 equals 7. 2 times 2 is 4. 4 plus 3 is indeed 7. So this check does work out. Now, some of the times the check isn't going to work out. So even though I boxed this in right here, it is useful to do this at the end, really. Okay? So we can think of this as like, our answer to the equation. This is like our actual solution after checked. So it's good to write it in solution set form after you've checked it, just in case, because you're going to see in a moment that you could get two answers here for y, and one of them may or may not work, and thus your solution would only be one of those two answers. Now part C says the following: the square root of 18x squared minus the square root of 2x squared plus 3 equals 11. And what you'll notice here is that we have different radicands, but what we can do is think of 18, and 18 is really 9 times 2. So we want to get this radicand to look like this one. So I can break this into root 9 times root 2x squared, and now I've got the 2x squared in both spots, which is really convenient. Square root of 9 is just 3, so I'm going to erase this and just put a 3 out in front. And now I could let u equal that entire expression, right? That entire radical 2x squared expression there, because it occurs in both spots. Had I done that earlier, it might have been a little bit messy with the 18, but now it's pretty easy. So now it's going to become 3u, right, because this is u, minus u plus 3 equals 11. And if I go ahead and combine my like terms at this point, I get 3u minus u is just 2u plus 3 equals 11. If I subtract 3, I get 8. Divide by 2, I get 4. So u equals 4. That's my u value. All right. Well, I want to figure out what x is. Well, this was equal to u, right? So we'll set that equal to this. Again, if this is equal to u and this is equal to u, then this is equal to this. So set these two equal to each other now. So again, radical 2x squared is equal to 4. Square both sides, we get 2x squared equals 16. Divide by 2, we get x squared equals 8. Take the square root, so x is equal to plus or minus radical 8. And again, I'm solving the equation, so I have two answers there. I'm not just coming up with the principal root. And if I simplify this, it becomes 2 root 2. Okay, so those are my answers for x. Now, we need to check our answers in our original to see that we do indeed have two solutions. There are two solutions so far, two answers so far. Let's figure out if those answers are indeed solutions to the original equation. So we start by writing our original equation, and let's check the positive answer we got first. So positive 2 root 2. And what you'll notice is that if you want to, you can use this positive radical 8 to help. It might be easier to plug in, but you could also plug this in. It makes no difference. So our original equation said radical 18 times x squared, so that's going to be just 2 root 2, and that's going to be minus radical 2 times x squared, again 2 root 2, and it's going to be a plus 3 equals 11. Okay, so this again is our check to see if it works, so we're checking that 2 root 2 is an answer. Well, if you square 2 root 2, you have to remember to distribute the square root of both of these. This is going to become 4, and this is going to become 2. Right? Squaring 2 is 4, squaring root 2 is just 2. So 4 times 2. So this is going to become radical 18 times 8 in there. Okay, 18 times 8, which is 144. And then over here we're going to get, this is going to be radical 2 times 8, which is just 16. Plus 3 equals 11. Square root of 144 is 12 minus 4 plus 3 equals 11. 12 minus 4 is 8. 8 plus 3 is indeed 11. That checks out. Now, I should go on and check the second answer, but I'm actually going to stop, and here's the reason. Whether this answer is positive or negative has no effect on the check, because notice that we're going to end up squaring this anyway. So if I were to just put a negative sign here and here, right, that's inside the parentheses, please. Okay, extend your parentheses. Put a negative there. When I square them, they're both going to still become positive 8. Right? When you square a negative, it's still positive. So that one will also check. So in this case, our solution is both plus or minus 2 radical 2. Example 2 says, solve the radical equation and check your answer. Now we're going to see some ones where we might have to look at some quadratics along the way. So let's take a look. Well, in the first one, the radical expression is already isolated. So let's start by squaring both sides of the equation. So here, if I square the left-hand side, it just gets rid of the radical, but I square the right-hand side, it becomes x squared. So I get 7x minus 12 equals x squared. Well, whenever we have a quadratic here, we have to move everything over to one side. So 0 equals x squared minus 7x plus 12. Factoring this, I'm going to get x minus 4, x minus 3, giving me two answers, x equals 4 and x equals 3. So this is one of those cases where we indeed have to check both. So let's check them both. So the first one I'm going to check is going to be 7 times 4 minus 12. Well, that's got to equal 4. Let's see, that's the first check. So this is going to become 28 minus 12 equals 4. 28 minus 12 is 16. Well, is radical 16 4? It is. So 4 works. Let's check 3 next, and we'll do that in black. So we're going to have 7 times 3 minus 12, and that equals 4. 7 times 3 is 21 minus 12. I'm sorry, not 4, that equals 3. Let me change that, right? 3, because we're checking x equals 3. That equals 3, so this is going to be radical 9 equals 3, and radical 9 does equal 3. That is true. So these are both correct. So our solution set for part A is x equals bracket 3, 4. Now part B is a little bit tricky because again the goal is to isolate the radical. So we start by taking this x that we see here, and we got to move it over first. Let's move this whole thing over here. But the issue is going to come into hand when we notice that, well, we're going to have this 3 here, and it's going to be tough to get rid of it, or else it's going to make it messy. But we'll see what we do. So let's take a look. We've got 3 radical x plus 1 minus x equals 1. So we'll add the x over, leaving us 3 radical x plus 1 equals 1 plus x. And then at this point, we could try and get rid of this 3 by dividing by 3, right? Divide by 3, divide by 3. But then we're going to have to square this, and it's going to be messy. So let's just leave it over there for now. It doesn't really matter. Here's the reason. Watch. When I square it, it has the same effect. When I square it, it becomes 9, right? And that becomes the quantity x plus 1. Because I have to square both terms, remember? When these are multipliers, you have to square them both. It would be the same effect as if we had a 3 down here. Right? If we had all this divided by 3, we'd have to square it anyway. So we'd put a 9 down here when you square it, and then that 9 would come back up over here. So in the end, it's the same thing, really. But this equals on the right-hand side. Now, you can't forget that this is an example you have to FOIL. It's really 1 plus x times 1 plus x, or x plus 1 times x plus 1. So this is going to become x squared plus 2x plus 1. And now we just have to simply go through this problem and solve. So distributing the x becomes 9x plus 9 equals x squared plus 2x plus 1. Subtracting the 9x from both sides, this is going to become a negative 7x, right? Because we have this 2x, and we'll subtract this 9x. We'll have the 1 minus the 9 giving me negative 8, and that equals 0. And now what we have to do is go ahead and factor. And it looks like it's not factorable at first, but 8 and 1 works. Please don't forget about 8 and 1. So this factors into x minus 8, x plus 1, giving me answers of x equals 8 and x equals negative 1. So now we have to go ahead and check 8, and we have to check negative 1 in the original equation. So in the original equation, again, we have 3 times the square root of, and I'll check 8 first. So it's going to be 8 plus 1 minus 8 equals 1. Again, this is where x was in our original equation, in those two spots. So if I check this, I'm going to see that I have 3 times the quantity square root 9, right? So this is just 3 times 3, really, right? Because this is really square root of 9. Minus 8 equals 1. 9 minus 8 equals 1. That is true. That is true. And let's check negative 1 now. So we're just going to replace here and here with negative 1. So 3 square root negative 1 plus 1 minus negative 1 equals 1. Let's take a look to see if that's true. This is going to be 3 times the square root of 0 minus a negative 1 is really plus 1 equals 1. So this is going to become 0, right? So 0 plus 1 equals 1. That's true. 0 plus 1 is indeed 1. So this checks out. So our solution set for this problem is x equals brace negative 1 comma 8. There's our solution set for this second example for number 2. Now part C is a bit tricky because we're going to notice right away that we have two different radicals. And unfortunately, those radicals are not really similar, so we can't try and factor something out like we did earlier and use that U method. But what we can do is we can try and isolate one of those radicals still. So I'm going to go ahead and add the radical x plus 6 to the right-hand side, giving me radical 2x minus 2 equals 1 plus radical x plus 6. The reason I'm doing that is because now I've got the radical isolated on the left-hand side, I could square both sides. And this right-hand side is going to be a mess to square, but the left-hand side is easy. That becomes 2x minus 2. But the right-hand side, we have to remember that what this really is 1 plus root x plus 6 times 1 plus root x plus 6. That's what this really is. So we're going to have to FOIL this. So the left-hand side, again, is still simple. I'll leave that alone. The right-hand side, FOIL, gives me 1 times 1 is 1. The outer is going to give me 1 times radical x plus 6, which is just radical x plus 6. The inner is going to give me 1 times radical x plus 6. And then last is going to give me radical x plus 6 times radical x plus 6. Well, remember, like radical 5 times radical 5 is just 5, right? So when I multiply radical x plus 6 times radical x plus 6, it's just x plus 6. I can keep going now. Let's go ahead and take a look to simplify this further. I still have 2x minus 2 equals, this is 1. Now, there are 2 of these, so 1 plus 2 root x plus 6. And this is still plus x plus 6. Let's move everything over now that's not involved with that radical to the left-hand side to isolate that radical. So we kind of did like a radical within a radical in a sense. Because we isolated a radical once already, now we have to isolate it again. So let's move the x plus 6 over and the 1 over all at the same time. So this I'm going to get rid of and just make this a 7, right? Because 1 plus 6 is 7. And then I'll subtract the x on the left-hand side and subtract the 7. Subtracting the x from this 2x over here already makes it just x. And then we have this negative 2 minus another 7 is going to be negative 9 or minus 9. And that equals parentheses 2 times root x plus 6. Now, at this point in time, we have to square both sides again. Let's go ahead and square both sides of this now. So squaring both sides, we're going to see that we get x minus 9 quantity squared equals, it's going to become a 4, and this is going to become x plus 6. Again, from doing this, right? Distributing the square to both of these. X minus 9, that quantity squared is going to be x squared minus 18x plus 81, and that equals 4x plus 24. Moving everything over to the left-hand side, and we can see that this is just a lot of algebra. So subtracting 4x is going to give me 22x there, and then 81 minus 24 is going to give me 57. This factors pretty easily because the only real multiples of, or factors of 57 are 19 and 3 and 1 and 57. And 19 and 3 happen to add up to 22. So we have x minus 19 x minus 3, giving us answers of x equals 19 and x equals 3. Now we have to check both of these in the original equation still, so I'm going to have to move up to give myself more room here. So those are my two answers, 19 and 3, so let's check 19 first. So checking that in the original it's going to become radical 2 times, this is going to be the 19 right here, minus 2, and this is minus radical, again here's the 19 occurring, 19 right there, plus 6 equal 1. Well, we have to go ahead and simplify this. If simplified, we have 2 times 19, which is 38. 38 minus 2 is 36. This is radical 36. Minus, and this is 19 plus 6, which is 25. That equals 1. Let's take a look. Is that true? We're going to get 6 minus 5 equals 1. That is indeed true. So 19 is one of the possible, or is one of the solutions. Now we have to check 3 as one of our answers. So we plug in 3 instead. The exact same process occurs. So what I'm going to do is simply just put a 3 in these spots here. Okay, the exact same process. 3 plus 6 is going to give me 9 right here, which makes this a 3. And this 3 over here is going to be 2 times 3 is 6. 6 minus 2 is 4, making that a 4. And the square root of 4 is 2. So we end up getting 2 minus 3 equals 1. Well, 2 minus 3 equals negative 1, so this does not check. So this answer must be rejected. So our solution to this problem is simply 19. Example 3 says to solve the quantity 3x equals 2 plus the quantity x radical 5 without squaring both sides. So it's tempting to try to square both sides, and you could do that, but let's try this without squaring both sides. And what you'll notice is that there's an x in 2 spots. So let's move this over first. Make it 3x minus x radical 5 equals 2. Then we can factor out of x, leaving behind 3 minus radical 5. All right, there's an x in both terms. So there's your GCF. And then divide by 3 minus root 5. Well, it's 2 over 3 minus root 5. How do you make that rational? Well, you multiply by the binomial conjugate. So let's simplify this by multiplying by the binomial conjugate. In doing so, in the numerator, we're going to get 6 plus 2 radical 5 all over the denominator. Well, the denominator is the difference of 2 squares. So first gives me 9, outer and inner give me 3 root 5 and negative 3 root 5, which cancel. And then root 5 by root 5 gives me root 25. There's a minus sign there. Simplifying a little bit further, we're going to see that the numerator becomes, or still remains, 6 plus 2 root 5. The denominator is 9 minus, well, this is really a 5, so it's all over 4. Well, that could be simplified even further because we notice that this is a monomial and this is a binomial, 1, 2 terms. So if every term in the polynomial up top, which happens to be a binomial, can be divided by the monomial, we can do that. Well, a lot of people are getting confused. Just think about factoring out a 2. If you factor out of the 2 at the top, right, it would look like this. And if you factor 2 out of the bottom, it would look like this. Well, if you factor something out of the top and the bottom, clearly they cancel. So really, what are we doing? We're getting this as our final answer, which is the same thing as just reducing everything by a factor of 2. Okay? So our final answer is the quantity 3 plus radical 5 all over 2.